Assalamu alaikum, my name is Muhammad Khan, and for today's lesson we got here is radioactivity. So without wasting any further time, let's proceed to our lesson. Natural radioactivity. So natural radioactivity is emission of radiation by unstable nuclei, and elements which emit such radiations are called radioactive elements. So what is actually a unstable nuclei? Unstable nuclei are the nuclei which got atomic number higher than 82. Nuclear transmutation. Nuclear transmutation is a process in which a parent unstable nuclide disintegrates into a more stable daughter nuclide with the emission of some kind of radiation. For example, iodine 130 can stable itself by decaying into xenon 130 with the emission of a beta particle. This is called a beta decay. This electron here which you can see is actually a beta particle. So there are three types of radiations through which an unstable nuclide can stabilize itself. It is alpha decay, beta decay and gamma decay. All three radiations have different properties. For example, alpha particle here is a helium nucleus comprising of 2 protons and 2 neutrons with a charge of 2e. When an alpha decay is occurred, the atomic mass of parent nuclide is decreased by 4, and meanwhile its atomic number is reduced by 2 with the release of helium particle or with the release of alpha particle which is actually a helium nucleus and energy. For example, a radium 226 can disintegrate into radon with a release of alpha particle and energy. And on second number we got here is a beta decay. When a beta decay occurs, the atomic mass of parent nuclide remains unchanged. Meanwhile, its atomic number is increased by 1 with the release of beta particle and energy. For example, a carbon 14 isotope can be turned into nitrogen with a release of beta particle and energy. Beta particle is a stream of high energy electrons with a charge of -1. As you can see here, beta particle comprises of -1 charge. On number 3 we got here is gamma radiation. Gamma radiations are actually high energy light photons of very high velocity. When a gamma decay occurs, both atomic mass and atomic number of parent nuclide remains unchanged. For example, a cobalt 60's excited nucleus can stabilize itself by release of gamma radiations. Gamma rays are usually emitted along with either an alpha or a beta particle. Now we got here is ionizing effect of all three radiations. First of all, what is ionizing effect? Ionizing effect is basically splitting matter into its positive and negative components. For example, in this picture, a neutral gas is split into its positive and negative ions with the reaction with alpha particles. These small violet circles are actually alpha particles. Alpha particles have greatest ionizing effect due to its large mass and charge. Due to its large charge, it has a very strong interacting power. That's why it got the highest ionizing power. Then we got here is beta particles, which have ionizing power less than alpha but greater than gamma rays. Beta particle have lower ionizing power due to its less mass and less charge. Then we got here is gamma rays. Gamma rays have the lowest ionizing power due to its neutral nature. Then we got here is penetrating power of all three rays. Alpha particle have lowest penetrating power due to its very high interacting nature, and beta particle has penetrating power more than alpha particle but less than gamma particle. And gamma particle have very high penetrating power and can penetrate through 30 centimeter of aluminum sheet. Now here is a summarized table of all three radiations. You can remember this easily, and it will help you in exams. Thank you students for staying, and you may ask your queries now. Also, please do not forget to subscribe this channel for more lessons like this.